Okay, folks, here we are. We're recording a VMware session here. And what I'd like to introduce to you is the future of Linux and computing in general. The concept behind this is containers and Kubernetes, virtual machines on steroids, and so on and so forth. What I'm bringing to you right now is a distribution called tinycore Linux. Now what I'm going to do is give you a quick demo of what this is, and then I'm going to back into it and explain it. tinycore is a very small operating system, very minimal. And when you install an application like a terminal, and I'm going to boost the size of my screen here by typing in a term font name, and then you have to select your font 10 by 20, and then this gives me a slightly larger monitor screen, so for the screen I can actually, might be able to see it. To see your fonts you do XLS fonts, and side note there, this is all old school X Windows stuff, not taught much anymore. But what I want to show you is that tinycore is running, and everything is running on a loopback device. So everything that you're running, that you load in tinycore, is running in RAM. Now I'm actually booting the operating system from a CD. So I have this little ISO image, and we'll get to the size of that in a minute. And this ISO image allows me to load my apps. And then when I save my apps, this is what happens. From the command line, you use this tool called file tool.sh-b. Oops, would help if I could spell tool right. And you hit enter, and notice it's saving it to mnt sda1 tce, and I look here. All my data is backed up for this system in 900K. What it does is it takes all these loopback devices, compresses them, stores them on disk, so when I go to reboot this system, notice I have reboot and I have an option for backup. That's where I'm going to back it up. I say OK. And then what happens is that this machine's going to reboot, and I'm going to boot the, this is 64-bit, and it's the latest version, and no reason to use this one or any other, it's just a nice demo. And there it is. And I've installed a few other things on this machine, like I've installed this terminal. So if I want to see this terminal, and let's do that again, URXVT, font name, and then I want to go with 10 by 20. Make it a little bigger so you can see it. There it is. Now if I do a DF, I am going to find my UX, there it is, mounted as a loopback. Even though I typed in UXRVT, that is it's a symbolic link to RXVT. So this operating system is used at Amazon for all their scan guns and terminals. So it's extremely widely deployed. Now the reason I want to bring this to your attention is knowing how this works with the loopback is where computing is going. So what I want to do now is type in exit, and now I'm just going to halt the system, and I'm going to hit shutdown and backup. Now I've got all the X Windows stuff installed on that one, but I don't need it. I can actually run a text version of this, and here it is. So here's my text version, and making the font bigger here is a little more difficult. But notice I've got very few things loaded. I've got very few things. Now you'll see I have IP route. This is where I get the IPA or IP link. all the IP commands and netstat and the ss command is showing me what it's running. The IP route 2 commands are the modern way to do configurations of networking. Old school, it's not obsolete, it's just not used in practice as much as ifconfig-a and then ipconfig for Windows and so on and so forth. The IP route commands are also available in Windows in the PowerShell. Side note, tinycore is very tiny. I want you to look at what I've got. I created a disk that is SDA1. I created it as 7.5 gig and it's 0% used. So I'm running this thing in RAM. And you can see my rootfs and tempfs are in RAM. And then when I type in my file tool, so let's add an application here, tce load IW. I want to install it and run it, and I'm going to call it RxVT, and I hit enter, see if it finds it. And notice what it's doing. It's loading a bunch of stuff for my RxVT, and it also knows that I don't have X Windows running. So when I try to run this, it's going to give me an error. Okay? I think. So it's installing all sorts of things for me. And it might very well be installing the X Windows subsystem for me. That would be pretty impressive. It's got font config, and there it is. So now it's there. And let's do the U. Can't open display. That's because I do not have X Windows running. Okay, and here's how you tell: echo $display. So I am on a pure TTY machine, and this is, it's nothing. There is nothing on this. This is a very, this is where the money is knowing how to manipulate this. And I want you to notice it's not running bash. It's running something called BusyBox. BusyBox is got to be one of the most clever pieces of software I've come across in a long time. It's been around forever, and they keep making it better and better. But what BusyBox is a multi-call binary. One code base, depending on how you call it from the command line, gives you all these commands. So you can see all these commands are part of BusyBox. Again, this makes it extremely small. So, very interesting things. Now, I do want to show you this as a side note. Notice BC, binary calculator, is not here. But the DC command is. DC is a stack-based calculator. So you put in your numbers, and then you have to tell it what to do with it, and then you have to print it. So this is like really old school, but this is a perfect way to understand stacks. This is a stack-based computer, and you have to say value operator. So it's called reverse Polish notation. Very important to know this. Not that you'll ever need it, but you need to know how this stuff works. Because stack-based computers and a stack-based VM is how WebAssembly converts all of its magic to run inside the WebAssembly virtual machine. It's a stack-based virtual machine. So is this command. So you can learn about stacks by playing with this. And you can install BusyBox on any Linux box. Okay, now, why am I showing you all this craziness? Well, here's another reason. Okay, so what I'm going to do now is I don't even have to exit this. So I'm going to back it up. No, I'm not. I don't want to back it up because I don't want to save my RxVT. So I'm just going to type in exit and then go up to the top here and just turn it off. Why? It's all in RAM. So who cares? Boom, dead. All right, now some other interesting things I want to bring to your attention is you have probably heard of Red Hat. Okay. Now I'm going to close this window. This is my VM, and this is all my KVM. So on my same computer, I'm running KVM and other such things. Alpine Linux is very much in the model of tinycore. It's just designed for server platforms. Tinycore is designed to re-provision very old hardware. Okay. And then also we have something called Silverblue. This is Red Hat's version, and what it does is when you boot Silverblue, you don't install any apps. They're all Flatpak. Now on Linux, on Ubuntu, we have snaps that look like this. Whoops. Snap list. So when you're installing Ubuntu, you have snaps that are installed. So let's say I want to install GIMP. Snap install GIMP. And what it does, if I can remember my password, is that this snap creates a loopback for the GIMP application. Think of this as a miniature container running on my local machine for GIMP. And when I don't want it anymore, I just say snap remove or snap uninstall GIMP. Poof, gone. And I don't have to worry about installing it and worrying about all the dependency libraries. So this idea of snaps, and Red Hat's version is called Flatpak, and it's spelled funny. It's actually spelled Flatpak. And these are cross-platform types of tools that allow you to load various applications without installing them completely on your machine. Okay? This is nothing more than Docker containers for the operating system. So this idea of containerization is definitely in your future because it's so important and it makes things much easier to manage. So you treat your fleet of computers like cattle rather than each one as an individual pet. Okay? So you don't take hours and hours and hours tweaking each individual machine. You set up a script, you run Ansible, boom, there's your machine. Okay? I probably should have chose one that's a little smaller, but that's all right. And then what happens when I do snap list, you'll see GIMP, and then when I run GIMP, it runs from this shared memory space using the loopback device. So the reason I showed tinycore is that is kind of the seminal work of where loopback got its start. It actually got back earlier than that using something called chroot, but it all kind of fits together. So once you see how this behaves in one way, you can understand how it works in other locations. Raspberry also supports snaps. So you can install a lamp stack, you can install all these fun things, and you don't have to mess up your base install on the Raspberry. And you could also run tinycore on a Raspberry, which I did, and man, it makes a Raspberry fast. It was quite interesting. So now while that's grinding away, what I want to do is go back to tinycore and show you something. Look how big that is. 11 megabytes. And that's why you can run it in RAM. Okay? This is the one, the Core Plus. This is all 32-bit here. This is the main push is 32-bit. And you can actually, with 106 megabytes, you can't even find a pen drive that small anymore. that has everything you could possibly want to run on this. Could you make it your basic operating system? Yes. I don't recommend it because that's not what it's optimized for. Because eventually you're going to need something more beefy. But for something small and light on extremely old hardware, and you want to, I use tinycore as a secondary boot option to do recovery, because it makes it really easy to boot, fix something, and then reboot, and go back to normal. Okay, but this is why I wanted to show it to you. Is that where are you going to find an operating system that fits in 11 megabytes? And then here's the other ports. Here's the Raspberry, and this is the TZZs. This is the tinycore compiled gzip thing, and then this is the dcore. This is their experiment using apt-get type of tools from the Debian project on the tinycore platform. I have not messed with that much, but I highly recommend that you read the book if you are interested about tinycore. Now remember, it's used all over at Amazon, so if you know this, you've got a few interview questions already asked. Okay, it's extremely hacked, but nevertheless. So on that note, that's where I will stop my lecture. And let's see, it worked. It's still grinding away here. So needless to say, that's all you got to do for snaps. You say snap install, and then you can install all sorts of things. There are some things that get into problems if you have something like the Jupyter Notebook or Jupyter Hub and you try to run it as a snap. You're going to get into library dependency issues, and then in that case, if you're interested in doing such thing, let me know and I'll teach you how to set up a virtual Python environment. And the virtual Python environment allows you to segment all that stuff, and then you could add your snap to that. So now when I do my snap list, looky there, I got my GIMP and all the other things that it needed to support. So now when I run GIMP, whoops, I get my, there it is, my monstrous GIMP package ready to rock and roll and do all these fun things with photo manipulation. It's like Adobe Photoshop. Okay, so on that note, I will stop. Thank you for your time.